Let's look at one that's very similar to 99B. We're dealing with partial fraction decomposition. And you want to be careful. Of course, the instructions tell you that you're going to have to use polynomial long division. And the reason is the degree of the numerator is 3, the degree of the denominator is 2. For partial fraction decomposition to work, we have to have the degree of the top to be less than the degree of the bottom. If it's not, as this in this case, you have to do polynomial long division. And so how do we do that? Well, again, we are dividing by the denominator. That's our divisor, x squared plus 5x plus 4. Dividing into the numerator sometimes called the dividend. And it's just like we do regular long division with real numbers. And how do we proceed? Well, first thing is you count the number of terms that you have here, and you want to make sure that you have placeholders if needed. So if it was, instead of x squared plus 5x plus 4, if it was just x squared plus 4 I was dividing by, I would actually plug in a 0x, right, which is really 0, but it's a placeholder just to keep things organized. So you want to make sure you're in decreasing order, x squared, x to the first, and then the constant term. So you always want to be decreasing order. Same with what you're dividing into. If you need any placeholders, put them in. Got 3, 2, 1, 0, so we don't need any. And then how do we divide? We first divide 3 terms into 3 terms, and the way we do it is we look at the first term and divide that into this first term. So how many times does x squared go into 5x cubed? How many times does x squared go into 5x cubed? Answer, 5x, right? 5x times x squared is 5x cubed. And where do we put that 5x? Just like long division, we put it to the far right where we're dividing into 3 terms, so right here. And it should line up. Notice all the terms right here vertically all have x terms. All these are x squared terms and so on, constant terms. That's the way it should be if you've got placeholders and you have them in descending order. So now what do? We multiply this 5x times x squared, give me 5x cubed. 5x times 5x is 25x squared. 5x times 4 is 20x. So you have to distribute, that through. And then be real careful here. We're subtracting, not adding. So 5 minus 5 is 0. 27 minus 25 is 2x squared. 34 minus 20 is 14x. And then what we bring down the 15. And then we redo it all over again, x squared into 2x squared. How many times does x squared go into 2x squared? 2 times. Distribute this 2 through. 2x squared. 2 times 5 is 10x. 2 times 4 is 8. And then again, I subtract. 2 minus 2 is 0. 14 minus 10 is 4. 15 minus 8 is 7. And that's my remainder. And so our answer is that this fraction is equal to what? 5x plus 2 plus our remainder over our divisor. Okay, so I've done the polynomial long division. Now it's easy to integrate 5x and 2, we know that. But what about this thing? Well, notice the degree of the top now is 1 and the degree of the bottom is 2. Now I can use partial fraction decomposition on this. So the way to proceed there is to first factor this denominator. So x squared plus 5x plus 4 factors as x plus 1 times x plus 4. So these are 2 linear factors. We have 1 linear factor, x plus 1. So that gives me 1 fraction, a divided by x plus 1, x plus 4, b over x plus 4. So linear factors have constants above in the numerator. So I've got to find a and b. So what I do is I multiply both sides of this equation by our least common denominator of x plus 1 times x plus 4. Of course, over here, we'll just get 4x plus 7. Here, the x plus 1s will cancel, leaving a times x plus 4. Here, the x plus 4s will cancel, leaving b times x plus 1. Now, you could solve this by the method of undetermined coefficients, but you can also do the shortcut, which is to note that in this case, if x is equal to -4, what do I get over here? -4 times 4 is -8. Negative 16 rather. I'm adding, not multiplying. -4 times 4 is -16 plus 7 is -9. And then -4 plus 4 is 0. So that's all 0. And then -4 plus 1 is -3. So I get b times -3, or -3b equals -9. I can divide by -3 and get b is 3. Also, I could do x is -1, which gives me -4 plus 7 is 3. And then -1 plus 4 is 3. So I get 3a. Of course, this goes to 0. And so I get a is 1. And that's how I solve that partial fraction decomposition. So a is 1, b is 3. And now I can rewrite this integral this way. Now I can integrate because, well, first of all, 5x is going to be just 5/2 x squared. Antiderivative 2 is 2x. Here, if u is x plus 1, du is dx. And so you get 1 over u, which is what? The log of absolute value. So you get plus natural log of u, which in this case is absolute value of x plus 1. And then you got 3 over x plus 4. So you're going to get 3 times the natural log of absolute value of x plus 4 in a similar argument. And don't forget your plus c. And that is the final result with the fun method of partial fraction decomposition. So I hope that sort of clarifies how to proceed with these type problems.